Alright, so one of the things you're asked to do in algebra is to look at the equations for various lines and figure out whether those equations are describing lines that are parallel to each other or perpendicular to each other, or neither. Maybe they just cross. So why do that? I don't know, but since you'll need to know how to do it, here's how to do it. So the key is so parallel. What are we talking about? Parallel and perpendicular. This line. Let's see. This line and this line are parallel. They never cross. Um, this line and this line. Let's see. Are perpendicular. They well, it's not quite right. Let's see. Let's get that a little bit. It's kind of eyeballing it here. It's not exactly right, but yeah, it's worse. Um, anyway, when they cross, they need to form a 90-degree angle. So they're perpendicular. Okay. Um, this line and this line are neither perpendicular nor parallel. They just cross. Okay. Okay. So what are the slopes of these kinds of lines? So two parallel lines will have the same slope. Same steepness of the line. The slopes of perpendicular lines will be the negative reciprocals of each other. So, for example, if the slope of this one is 3/4, then the slope of this one would be, well, of this one would be -4/3. Flip it over and then flip the sign. So, and then the slopes of lines that just crossed, are neither equal nor negative reciprocals. They're just different. Okay? So when you have the equation of a line, you can figure out what its slope would be. So that's the key to this whole exercise is identifying the slope of a line from the equation for that line. So once you figure out the slope of each of the two lines that you're trying to compare, then you can put it in a category of are they parallel, are they perpendicular, or do they just cross. So identifying the slope is really the key the key thing here. So um, you can do that easily if the equation you're given is in the slope-intercept form, or the point-slope form, or the standard form. Um, Otherwise, if it's not in one of these three forms, you can rearrange the equation so that it is in one of these forms, and you can identify the slope. Okay, so if it's in the slope-intercept form, it's y equals something times x plus something, y equals mx plus b. This number will represent the slope. If it's in point-slope form, where it's y minus something equals something times x minus something, this number will represent the slope. And if it's in the standard form, you can rearrange it into slope-intercept and see, or just remember this little shortcut. The slope is -a over b, which is what you'd get, when you rearrange this in the slope-intercept form. So we'll use this, as a guide over here. And if one of these equations is not in one of these forms, we'll just rearrange it so it is. I think they all are actually. No, I think yeah. Yeah. Okay. So first step, we'll figure out the slope of each line, and then we'll put it in one of these categories. Okay, so this line here, y equals -2x plus 10, that looks a lot like this, y equals mx plus b. Yeah, so that's in the slope-intercept form. So the slope of that guy is -2. Now, what does this look like? Y minus 3 equals -2 times x minus 20,000. Does it look like one of these? Yeah, that's kind of point slope form. Y minus something equals something times x minus something, right? So the slope here would be this number, which would be -2. Okay? So the slope of this line is -2, the slope of that line is -2, so they have the same slope. So these are parallel lines. Parallel. Parallel. Parallel lines. Trying to remember the sign. I think the symbol for it is like that. I believe. Look that up just to be sure. I think that's parallel. And I think this is perpendicular. Um, okay. Yes. Okay. So let's look at this next set of lines. So y equals 1/3 x plus 4. That sounds a lot like y equals mx plus b. So that's slope-intercept form. So we can just grab the slope there. Slope there is 1/3. Um, now, is this in a form? Well, if we put a 1 here, um, this looks like standard. Something times x plus something times y equals something. So in the standard form, the slope is, I mean, you could rearrange it so it looks like slope-intercept. You know, you would subtract the 3x, put it on this side, um, and then you would be done, actually, for that one. So the slope is, or you just remember the shortcut, slope is negative a, so if this is a, this is b, b, and c. It'd be negative a over b, so negative 3 over b, which is 1. Okay, so the slope of this is 1/3. The slope of that is negative 3 over 1. So this guy is this guy flipped over and then made negative. So these are negative reciprocals of each other. Therefore, these lines are parallel to each other. So we call this A and this B. Let's say like line A is parallel or perpendicular to line B. Perpendicular. Perpendicular. Okay. Now let's look at this pair of lines. 5x plus 2y equals 10. That's standard form. Something times x plus something times y equals something. So in the standard form, the slope is negative a over b. So negative 5 over 2. Now what is this? Y minus something equals something times x minus something. That's this point slope. So our slope is just this thing outside the parentheses. So negative 5 over 2 is the slope of that line. So these slopes equal to each other, so these lines are parallel, parallel lines. All right, last one. Y equals 8x plus 3. Slope-intercept. Slope is 8. 5x equals y minus 8. You know, is this one of these nice little forms? Negative. So let's rearrange it. Let's check out this. Let's just make this slope-intercept. We'll get y by itself on one side. So add this 8 to get it over on the other side. So we've got 5x plus 8 now equals y. Now I could just swing that around. Y equals 5x plus 8. So that's in slope-intercept form now. So this would represent my slope. So my slope is 5. 8 and 5 are not equal, and they're also not negative reciprocals of each other. So these lines just cross somewhere. There could be a symbol for that. I don't actually know what it is offhand. But these lines intersect. They're not parallel and they're not perpendicular. They're just, you know, normal intersecting lines. All right, there you go.